Now let's have some fun. We're going to learn how to modify an existing image using AI, and giving it a new stylistic twist while preserving its core elements. Let's start by adapting our basic text-to-image workflow. The key change here is replacing the empty latent image with an actual image. But before we can do that, we need a VAE encode node, along with a little more explanation on what a VAE even is. VAE stands for Variational Autoencoder. It's a crucial component in Stable Diffusion models that acts as a bridge between the pixel space of images and the latent space where the AI operates. Think of it like a translator. The encoder part of the VAE takes a regular image and compresses it into a compact representation that the AI can work with. This is what we call the latent space. The decoder does the opposite. It takes the AI's output in the latent space and converts it back into a regular image that we can see. Now that we have an understanding of what the VAE encode and decode nodes do, let's set up our workflow. First, add a load image node. This is where you'll select the image that you want to modify. Connect this to a VAE encode node. Also, connect the VAE output from your load checkpoint node over to this VAE encode node. This ensures we're using the same VAE for both encoding and decoding. Next, we need to ensure that our input image is the right size for our model. Add an upscale image node between the load image and VAE encode nodes. This node has several important settings. The first is width and height. Set these to a reasonable default of 512 by 512 pixels. That's because most Stable Diffusion models are trained on 512 by 512. However, if you're using a model with different native dimensions like Stable Diffusion XL, change it up to 1024 by 1024. You can play with this though, so adjust accordingly. Next we have the upscale method. We'll use bilinear, which offers a good balance between quality and speed. Other options include nearest exact for faster but lower quality results, or Lanczos for higher quality images but slower processing. Then we have crop. Set this to center. This ensures that if your image isn't a square, it'll crop from the center rather than stretching or squashing the image. Remember, the resolution you choose here is crucial. While 512 is standard, you can experiment with other resolutions. Just keep in mind that larger resolutions will require more VRAM and processing time. If you're working with limited resources, stick to 512 or even 448. Lastly, take the output from your VAE encode node and plug that into the latent image of your K-sampler, because remember, it expects a latent image for the input, and instead of an empty latent image, we're going to need to offer it something. Now let's turn our attention back onto the K-sampler node. Your focus here will be on the denoise setting, which will be key in controlling how much your input image is modified. Think of denoise as a spectrum from 0 to 1. At 0, you're essentially just passing through your original image unchanged. At 1, the AI is creating a completely new image based solely off your prompt, ignoring the input image entirely. The sweet spot lies somewhere in between. By adjusting this denoise value, you can control the balance between preserving the original image and incorporating new elements from your prompt. A lower value, say around 0.3 to 0.5, will make subtle changes, while a higher value of 0.7 to 0.9 will result in more dramatic transformations. With this logic in mind, be sure to keep your denoise strength at 1 if you're sticking with text to image. Since there's no actual source image to paint over in this case, we want the AI to fully hallucinate the results. Experiment with these settings along with different denoise values to find the right balance for your project. Remember, there's no one-size-fits-all setting. It depends on your input image, your prompt, and the style that you're aiming for. And that's it. You're now set up on a basic image-to-image workflow in ComfyUI. You've learned more about the VAE, how to prepare your input image, and how to control the AI's influence on the final result. Play around with different images, prompts, and settings to see the wide range of results that you can achieve.